So in this problem, we have 3a plus minus 2b plus 5c minus 6d equals the null vector, where a vector, b vector, c vector, and d vector are the position vector of the points a, b, c, and d respectively. Then we need to show that the points are coplanar. Also, we need to determine the position vector of the points of intersection of the lines AC and BD. Okay, let us begin. So we'll start with the given conditions. It's given to us that we have 3 times a vector minus 2b vector added to 5 times c vector minus 6d vector, and that's equals to the null vector. We're going to rearrange the terms. We keep 3a vector plus 5c vector on the left hand side and transpose the remaining 2 vectors to the right hand side. So we're 2b vector plus 6d vector. Now if we add up the coefficients of a vector and c vector on the left hand side, so 3 plus 5, that adds up to 8. And the coefficient of b vector and d vector on the right hand side also adds up to 8. What we'll do, we'll divide both the two sides with 8. So we have 3a vector plus 5c vector over 8, and on the right hand side we have 2b vector plus 6d vector divided by 8. Now we're going to rewrite the denominator of each of the two expressions. So 3a vector plus 5c vector. Now we can rewrite the denominator as 3 plus 5, and we can rewrite the right side as 2b vector plus 6d vector whole divided by 2 plus 6. Okay, now let's try to understand each of the two expressions. Let's say we have 2 points. We have the point A and we have another point C. Now the position vector of point A, that's already given to us. It's defined by A vector. Position vector of point C is defined by C vector. Let's join point A and point C. Now let's say we have a point on the line segment joining A and C, and we're going to name it the point X. And we suppose that X, let's say it divides AC into ratio 3:5 internally. Then we can define the position vector of the point X. So position vector of point X according to the internal section formula. So we take 3 and multiply it with the position vector of point C. So that gives us 3c vector added to 5 times the position vector of A, so that's A vector. So this will be divided by 3 plus 5. So that means the left hand side of the expression tells us that we have a point X, the position vector of a point X, which divides the line joining AB into ratio 3:5. So let us consider another point B, and then we have the point D. B has the position vector B vector and D has the position vector D vector. Let's join B and D with the help of a line segment. Now we're going to consider a point. Let's call it the point Y. We're going to consider the point Y on BD such that Y divides DB into ratio 2:6. Then we can use the internal section formula to define the position vector of point Y. So position vector of point Y, that's going to be 2 times the vector B added to 6 times the vector D divided by 2 plus 6. Fine. So here we have the position vector of the point X equals to the position vector of point Y. Now what does it mean? So we have 2 different points and the position vector of each of the 2 points are the same. Now that only tells us that means it's exactly the same point, but we can say that X is the, let's call it X because X equals to Y. X is going to be the point of intersection, the point of intersection of the line segment AC and BD. Now this is only true, this is only going to happen if A, B, C and D, these 4 points are coplanar. So we have successfully showed that the following points A, B, C and D are coplanar, provided we have 3a vector minus 2b vector plus 5c vector minus 6d vector equals to the null vector. Okay, now our next goal is to determine the position vector of the points of intersection of line AC and BD. So we have already defined the position vectors of the line AC. So this is going to be the position vector 3a vector plus 5c vector over 3 plus 5, and the position vector of Y, that's going to be 2b vector plus 6d vector over 8.